Welcome to this video. This video we will look at what is Azure Service Bus messages and serialization. Before going to start, we need a Azure subscription, Visual Studio and a basic understanding of C# coding. I strongly recommend you to watch my previous video related to Azure Service Bus. I'll provide the links below description box. In this video, we will cover what is messages, what is serialization. Finally, we will do demonstration for serialization. Let us start with the messages. Messages are at the core of how communication happens between different components of a system. The message structure in Azure Service Bus is a crucial aspect that allows for flexible and reliable communication between distributed systems. A service bus message consists of two main parts, message body and message properties. Message body. The message body is the actual data payload that you want to send from one component to another. This can be various formats like JSON, XML, plain text, or binary data. JSON, often used for lightweight, structured data that is easy to parse. XML. XML is useful for data with a complex structure or when interoperability with the system that prefer XML is required. Plain text. We can also send the simple text message as well. Binary data. Binary data is used when sending files, images, or other non-textual data. The message body is serialized and sent across the service bus, where the receiver deserializes it to process the data. Message properties are metadata associated with the message. These properties are categorized into system properties and user defined or custom properties. System properties. These are automatically set by the Azure Service Bus and provide the essential information about the message. User defined or custom properties. Custom properties are key value pair that you can define it to include additional metadata with your message. These properties can be anything that help in routing, processing, or categorizing the message. We will discuss some of the system properties. Message ID. A unique identifier for the message, typically a GUID. It helps track the messages and can be used for duplicate detection. Sequence number. A unique number assigned by the service bus when the message is enqueued. This number is used for identify the order of the message in a queue. Enqueue time. The exact time when the message was added to the queue or topic. This helps in tracking the age of the message and managing the TTL. Delivery count. This counter track how many times a message has been delivered to receivers. If a message failed to be processed and is abandoned, the delivery count increases. When it reaches a maximum limit, the message might be moved to a dead letter queue. Time to live defines how long the message is valid in the queue. After the TTL expires, the message is either automatically deleted or moved to the dead letter queue. Locked ending. When a message is received using the peak lock mechanism, it is locked and cannot be processed by another receiver until this time elapses. Partition key. Partition key is used to ensure related messages are processed together in the same partition. It is crucial for ensuring messages ordering across the multiple receivers. Session ID. Session ID is used for session-based messaging. Messages with the same session ID are grouped and processed together. Also, they maintaining their order. Reply to and correlation ID. Reply to and correlation ID is used in a request response pattern. Reply to specifies the queue or topic to which the response should be sent, while correlation ID is used to match the response within the original request. Dead letter reason. It provides information on why a message was moved to the dead letter queue and it's helpful for troubleshooting. We will look at some of the common custom properties. Priority. Priority indicates the importance of the message. which can be used to process high priority message first. Message type. It specifies the type of the message. Example order notification. It is helping the receiver to handle the message appropriately. Region. It indicates a geographical region useful in a scenario where the processing needs to be region specific. Correlation data. Any additional data that help in correlating this message with the external processes. We can think of message properties in Azure Service Bus as similar to headers in other messaging system or HTTP request. Message properties in Azure Service Bus serve a similar role to header, but they have some differences. Message properties can be more complex. In addition to simple key value pairs, message property can carry more structured data and are more tightly integrated with the messaging system's features, such as transaction sessions. Message properties are not just about the transmission of message over a network, but are also deeply integrated with the behavior of the messaging system itself, like message locking, TTL, and dead lettering. So, message properties in Azure Service Bus aren't technically called headers. They function in much the same way as headers do in other systems, providing metadata that influence how the messages is handled, routed, and processed. If you find it easier to think of them as headers, that comparison works well in most of the context. The structure of a service bus message is designed to provide flexibility, reliability, and control in how data is transmitted and processed across distributed systems. Understanding the component of a message is essential for designing robust messaging solutions in Azure. We will look at what is serialization in Azure Service Bus. Serialization is the process of converting an object or data structure into a format that can be easily stored or transmitted and then deserialized back into its original form when needed. In the context of Azure Service Bus, serialization is essential for encoding the message body. Some of the common serialization formats are JSON, XML, binary formats, text, and custom formats. Purpose of serialization. Transport. Message need to be serialized to be sent across the network from the sender to the service bus and then to the receiver. Storage. Messages are stored in a queue or a topic in serialized form until they are consumed. Interoperability. Serialization ensures that different systems, possibly written in a different programming language, can exchange data reliably. Serialization process in Azure Service Bus. Serialization on the sender side. The message body is serialized into a format like JSON, XML, or binary. The serialized data is then encoded into a byte array, which is the format that Azure Service Bus used to store and transmit the message. Custom properties might also be serialized, especially if they are complex objects. Transmission. The serialized message is sent over the network to the Azure Service Bus, where it is stored in the serialized form in the queue or topic. Deserialization on the receiver side. When a receiver receives a message from the queue or topic, the byte array is deserialized back into the original format. The receiver then processes the deserialized message body according to the application's logic. Next, we will do the demonstration. In this demo, first we will serialize an object and we will try to send this serialized object into a topic using console application. Then we will try to retrieve the message from the topic and deserialize the message using console application. Finally, we will display the message in the console application. Go to Azure portal. I have already created a service bus named as eLearn. Also, I have created one topic and a subscription. Topic name is notification and the subscription name is text sub. We will try to send messages from the console application. Go to Visual Studio. I have already created projects for sending and receiving message from the topic. In this demo, I am going to use .NET Framework 8. In this solution, I have created two console applications, one for sending message and another for receiving messages. Also, I have created one DTA project as well. This is our message sending console application. Inside the DTA project, I have already created a notification class. This notification class we are going to serialize and deserialize. For the serialization, I am going to use newtonsoft.json package. I have already installed newtonsoft.json package from NuGet. We need to create an object of notification. Then we need to serialize that object into a JSON string. Then we need to create a message object. Also, I am setting some system properties like subject and content type. Content types helps define the format of the message body, which is especially important when communicating across the different service, platform or programming language. By using content type, you can avoid issue with the incorrectly processed messages and ensure proper deserialization and handling. Finally, we will send the message asynchronously. We will try to run the application. Now, message is successfully sent. We will verify the topic. Go to Azure portal. You can see the one message is received. We will try to receive the message from the topic. Go to Visual Studio. This is our receiving console application. After receiving the message, we will deserialize the message body and we will write the values into console. We will try to run the application. Now you can see the values displayed on the console. We will check in Azure portal as well. Go to Azure portal. Now we don't have any active messages. Serialization is a key component in Azure Service Bus messaging, enabling data to be efficiently transmitted and stored in a way that both the sender and receiver can understand. The choice of serialization format depending on the specific need of your application, including consideration of performance, readability, and security. Understanding and implementing the serialization correctly is crucial for building robust, scalable messaging solution in Azure. In this video, we covered what is Azure Service Bus message, then we discussed what is serialization, and finally we did the demo. I hope everyone understood this session. If you have any question, please put them in the comment section below. Thanks for watching.